So guys, this will be the last video in figuring out the equation of an exponential function from a graph. I do want to say before we get started, all of the graphs that show powered by Desmos in this video, I did use the Desmos calculator to make those, so I do want to make sure that I give that credit to Desmos for using their calculator. So the equations that we're coming up with now are equations for graphs that have been shifted vertically. So vertically means up and down. And then translation is another word that just means shifted. Or you can think of it as meaning slide. So the graph is going to be slid up or down a certain number of spaces. Now, with that, you have to keep in mind that exponential functions have what is called a horizontal asymptote at the x-axis. That basically means that you have an invisible barrier at the x-axis that prevents the function from ever going past the x-axis, actually from ever even touching it. So it's like, as we followed the function showing growth here, if we were to go backwards, it's almost like the graph wants to level off at the x-axis. Same thing for the decay function as well. And the reason for that is because of that asymptote. When you have a vertical translation, what happens is that asymptote gets shifted along with the graph itself, okay? So what you've got to remember then is all that has happened is your graph has been shifted, and you just have to figure out how far it has been shifted and then count back to the x-axis. The number of spaces that you move will tell you the vertical shift. It will tell you how far you've moved up or down, that sort of thing, okay? So let's actually look at an example here. So on this one, the equation in black, the function in black there, its equation is y equals 2 to the x. And I'm going to go ahead and say the graphs in purple and in red are that exact same graph. Just the one in purple has been shifted up and the one in red has been shifted down. So we need to figure out, well, how do you come up with the equation then for those that have been shifted? Well, let's start with the one in purple. What you've got to notice first, guys, is where the function is leveling out. It's leveling out around where y equals 3. That means that at y equals 3, that's where your asymptote is now, it's now located there. So you've got to think it should be down at the x-axis. To get to the x-axis, you have to go down 3 spaces. So what you then have to do, okay, what you have to do in examples where you don't have the translated graph and the original graph on the same graph, what you've got to then do is just count your spaces. Count how far it has to take. You have to move that function to get it back to where your asymptote is at the x-axis. For that purple function, we have to move it down 3. So that means then that each point on that purple graph, you want to move down 3. So the y-intercept on the purple graph is at 4. If we move it down 3, it ends up at 1, which is the y-intercept for the function in black. If we move the next point on that purple graph down, we end up here, which is back on the function in black. And if you do that for each point, you land back on that function in black. So because you're landing on that same function, okay, it's the exact same equation, all right, with one exception. Because the purple graph is 3 spaces above where it should be, that asymptote has been shifted 3 spaces up. Each one of the points has been shifted 3 spaces vertically. Your new equation then, all right, not new equation, your equation for the purple graph is going to be y equals 2 to the x, but then we have to say plus 3 on the end. This is saying that we're taking that graph of y equals 2 to the x and we're just moving it up 3 spaces. So then for the function in red, it's the same idea, only it has been shifted down. Its asymptote, its barrier is at y equals -3. So it is 3 spaces below where it should be. So every point, okay, on that red function needs to be moved 3 spaces up. When we do that, So the y-intercept for the function in red is at -2. If we move it up 3 units, we land back on the y-intercept for the function in black. If we take the next point and move it up 3 spaces, we land back on the function that's in black, so on and so forth, okay? So because we're landing on that same function, that one in black, the equation for the function in red will be y equals 2 to the x as well. But because it is 3 spaces below where it should be, it will be y equals 2 to the x minus 3. And that's all there is to it, okay? So when we look at one like this one, where we just see the graph that's been moved, well, what we notice is that the function is leveling off where y equals -1. Okay, so that barrier is 1 space below where it should be. So that means that every point on that graph, we need to move it up 1 to move it back to where it should be, okay? Basically, we're moving it back to where it was prior to being shifted up or down, okay? So the y-intercept on that function in black right now is at 3. If we move it up 1 space, we end up at 4. Okay? Then we find the next point on that function in black. So that would be this one right here. If we move it up 1 space, we end up here. And then the next point ends up here. So then if you want, you can connect those points, and that way it actually kind of makes the graph, okay? So we'll sketch that. And what you're doing there, guys, is you're coming up with the equation, okay, of that function in black before it was shifted, okay? So we've got to come up with the equation for that purple function, okay? That's the first part here. So if it helps, make a table, and let's write down what our points are. So the y-intercept is at 4. Then our next point, where x is 1, y is 2, and where x is 2, y is 1. So this function, okay, whether you're looking at the black one or the purple one, is showing decay, all right? So we are to go from 4 to 2, we divide by 2. To go from 2 down to 1, we divide by 2. Or instead of dividing by 2, we're multiplying by 1/2. And we know that the y-intercept for that purple function is 4. So the equation will be y equals 4 to the 1/2 power, 4 times 1/2 to the x power. But what you've got to remember, guys, is the equation that we're trying to come up with here, ultimately, is the one for the function that is in black. This is the equation for the function that is in the purple. The equation that's in black, it was shifted down 1 space from this right here. So what you've got to do is put a -1 on the end. That is the equation for the function that is in black, okay? We'll do one more. So on this one here, the barrier, the asymptote, is at y equals 2. So it looks like it is 2 spaces above the x-axis. So it's 2 spaces above where it should be, okay? So you do the same thing with this one that we did with the last one. All right, find your points, and each one of them needs to be shifted down 2 units. That'll bring everything back to where it should be. So the y-intercept on that function in black is a little bit hard to see, but it's at 11. So we need to move it down 2 spaces. Then we need to find another point, bring it down 2 spaces. Another one, we'll bring it down 2 spaces as well. And we'll connect those points and make that graph. Very poorly drawn graph, but Lord, that's a horribly drawn graph. That's still pretty bad, but we're going to make it work. So this is the graph before it was shifted. So we need to come up with that equation, and then we're going to add to that how that function in black has been shifted. So this function is showing growth. So we'll make a table. So this point right here is at -2, 1. Our next point is at -1, 3. And then our next point, the y-intercept, is at 0, 9. So to go from one point to the next, we're multiplying by 3. So our b value, our factor, is 3, and the y-intercept is 9. But what we're ultimately trying to do is come up with the equation for the function that is in black, okay, the one that has been shifted. We figured out that it had been shifted up 2 units from where it should be. So the equation for that function then is going to be y equals 9 times 3 to the x power plus 2. And that's it.